Good morning, good afternoon. This is going to be day 1 of 3.8 where we're going to be solving systems algebraically. The first, just filling out our notes, going through the steps. First thing you're going to do to solve a linear system using substitution is you're going to substitute the expression that is set equal to y into the other equation and solve for x. You're going to substitute that answer from step 1 into the y's equation and solve for y. So write this solution as an ordered pair x, y. So let's do some examples. So in my first example, I have what y equals. Y equals x minus 3. I have two equations here that have two variables, an x and a y, and I don't know what either one of them is. If I got rid of one of my variables, I could solve for my other variable. If I only had one variable, you can simplify down and solve. Well, substitution is going to substitute what I do know for y. I do know that it's x minus 3, and I necessarily can't simplify that down yet, but if I use this x minus 3 and substitute it in to my other equation for where y is, I can solve for x. So y equals x minus 3, I'm going to take that, and wherever in my second equation I see a y, I'm going to replace that y with x minus 3. So x minus 3 and then equals 2x. In this one now, I have two x's. I have an x on this side and an x on this side. I want to solve for x, so I need to get my x's only on one side. So I want to get the x off of this side. That goes away. Whatever I do to one side, I have to do to the other. I have negative 3 here left. 2x minus x. I have 1x left. And that's my goal. I'm looking for what 1x is. So, okay, where was I? So we found what our x is. Our x is negative 3. I could also just flip this around and write x is equal to negative 3. So I'm going to replace here my x coordinate with negative 3. Then I'm going to go back and choose either one of my equations because they are both in that y equals form. And I'm going to solve for y. So x here is going to be replaced with negative 3 minus 3. So negative 3 minus 3 is a negative 6. Y equals negative 6. I can replace that there. I will want to check with this one, just a quick check of if I multiply 2 by negative 3, do I also get the same thing here? So negative 6. I do. Because maybe we were doing our math wrong right away. We thought this might be 0. Well, this wouldn't be 0. I know I did some math wrong. So it's always good to check. Okay, let's go on to this next example. Well, here we have what y is already. So we have our y component or coordinate. So all we have to do is find what x is. So y is going to be replaced with 2. So 2 equals x plus 4. I need to solve for x. I need to figure out what number here plus 4 will get me 2. Well, if you think about it, when I add a number, or if I add 4 to a number, and this number is smaller than this number, x has got to be negative. But let's see. If we subtract 4 from both sides, I get negative 2 equals x. And that would be true. So negative 2 is my x. And I'm going to replace what I found for x into here. This here should make both of these equations true. Okay, next example. We have here y is equal to x minus 6. So I can take this x minus 6 and replace it with this y. So instead of writing y, I'm going to write x minus 6. And that equals 3x. Again, I want to solve for x, so I want to get x by itself. I'm going to look at, here I have 1x, here I have 3x, so I'm going to subtract 1x. I'm going to subtract the smaller one. And because here I have a variable and a constant. I want to keep that constant over there. I want to get all my variables to one side. So I'm going to subtract x. This goes away, becomes 0. I have negative 6 left equals, if I have 3 and I subtract 1, I have 2x left. I need to divide by 2 to isolate the variable. So negative 6 divided by 2 is a negative 3. 2 divided by 2 is just 1, so 1x. Again, I can flip this around, so it's x equals, or 1x equals negative 3. I don't have to write the 1, but I can. So there's my x coordinate. Now I need to plug this into one of my equations and solve for y. So here, I could choose the smaller one if I like to multiply better. So 3, whenever I see the x here, I'm going to replace it with negative 3. Y is equal to negative 9. I can also do a check real quick. Negative 3 for x. Negative 3 minus 6, does that equal y or negative 9? It sure does. Okay. My next problem is going to be getting a little more difficult. Now, this one is solved for y. This one is not. So I need to replace what this y is. Y is 3x plus 8 into this y right here. So everything else is going to stay the same. 8x plus, and remember, when they're next to each other, that means multiply. So we have to write parentheses. Multiplied by 3x plus 8, parenthesis, and then equals 12. When I have a problem like this where I have parentheses, I always need to distribute that 4 within here. This common mistake is forgetting to either multiply both times the 3x and the 8, or I see a lot of adding sometimes of 4 plus 12. Don't add, you need to multiply when it's on the outside. So I have 4 times 3, which is 12x, and then 4 times 8, which is a positive 32. Everything else gets rewritten the same way. Now I have 8x plus 12x plus 32 equals 12. I need to combine my like terms. So I have 8x and 12x, so that combines to become 20x because I added the 12 and the 8. Plus 32 equals 12. Now I have a constant with my variable term. I want to get rid of my constant. So minus 32. That becomes 0, goes away. Minus 32 from over here. So I have 20x equals 20, or 12 minus 32 is a negative 20. I need to divide both sides by 20 to isolate my variable. I have x equals a negative 1. So 1, I could put x into either one of my equations and solve for y. It's just going to be easier to put it into this one here. So my y equals 3, and now every time I see an x, I know what x is. We found out that x is equal to negative 1. So I'm going to put negative 1 in there. Okay, so y equals a negative 3, because 3 times negative 1 is negative 3, plus 8. Remember, you have to do that multiplication first, order of operations. So y equals 5. Alright, our last one. Again, I'm going to put this is what y equals. I'm going to put it in for y here. So I'm going to write 3x plus, and then 4 times what y equals. So 2x plus 1 equals 26. Distribute here. So 4 times 2 is 8. The x comes with it. 4 times 1 will be a positive 4. Hopefully I'm not. Okay, I rewrite everything else the same. Combine my like terms of 8 and 3. So 8 plus 3 is 11x. And then plus 4 equals 26. I want to get rid of my constant of 4. So this goes away. I have 11x equals 22. Divide by 11. Divide by 11. And x equals 2. So now I have 2 for my x, and I need to solve for y. So I'm going to go up here and I'm going to rewrite y equals 2 times 2 plus 1. So that's 4 plus 1. Y equals 5. Okay. That is all for day 1.